Hello, Assalamu alaikum. Today we will see lecture number 17 from the subject numerical methods. In the last lecture we talked about the finite differences and we took one finite difference as forward difference. We saw what is basically the forward differences and how can we construct the forward difference table. Today we will see one or two examples from the same topic. Basically this is not in your syllabus, but this will help you when you will actually start doing unit number 2, like when you need to do Newton's forward difference interpolating method or backward difference interpolating method, but and Stirling's and Basel's formula. There these things will help you in order to solve all such things. So given the table of, so this is the first question. Given the table of values as, so these are the data points which we are given, and these are all the function values corresponding to each data point which we are given. You know, we have to estimate. Interpolation is all about estimating the values, right? But in this particular question, what is asked about is find the order of the interpolating polynomial. See, these are the data points, but these are the data points of a certain equation. Okay, so what we have to do, we have to find the order of that particular polynomial which might be suitable for the above set of values. The first thing which we have to check is that our data points should be equally spaced. You know, for forward differences it's very important that we only work on the equally spaced data points. If you will see the difference between each data points there, that is same, common, 0.1. So that means we can solve this question. So we can write it like this: since the points over here means data points are, if they would not have been equally spaced, you can simply write that data points are not equally spaced, so we cannot solve this question using the forward differences. Since the data points are equally spaced, okay, we can use the forward difference table which is constructed below, which we will construct now. The first thing for solving this question is we have to construct the forward difference table, like I told you in the last lecture how we can construct that. So these are our xi values, these are the yi values. Both the values are given to us: 2.0, 2.1, 2.2, 2.3, 2.4, 2.5, 13.00. So the first thing is we have to check the first order forward difference of this polynomial. How we do that? That is when we talk about the differences, the difference between this point to this point, okay, that we will write over here, like delta y1 will be, what is y1 value? Y1 ka value is this one. Y1 will be equal to 14.261 minus 13.00, which will be equal to 1.261. Similarly, delta y2 will be equal to this minus this, so this will be equal to 1.387. then this value subtracted by this value, 1, that delta y3 will be equal to 1.519. delta y4 will be equal to this minus this 1.657, then this minus this delta y5 will be equal to 1.801. Okay, so this is the first order difference. We have to see how long we can go, what would be the highest order for this particular question, so that we can find out the order of the polynomial. Still there is a provision of subtraction, so we will see the second order forward difference. सेकेंड ऑर्डर फॉरवर्ड डिफरेंस किसके बराबर होता है? सेकेंड ऑर्डर फॉरवर्ड डिफरेंस होता है द डिफरेंस बिटवीन द फर्स्ट ऑर्डर फॉरवर्ड डिफरेंस. दैट मीन्स नाउ वी हैव टू डेल्टा स्क्वायर y1 बराबर होता है इन दोनों का सब्ट्रैक्शन के बराबर. 1.387 माइनस 1.261 दैट विल बी इक्वल टू 0.126. Similarly, delta square delta y2 will be equal to delta y3 minus delta y2. After subtracting the values, the value will be 0.132. Delta square y3 will be this minus this. The value will be 0.138. Delta square y4 will be equal to this minus this. So the value will be equal to 0.144. Delta cube yi, that means delta cube y1 will be this minus this, which is equal to 0.006. Delta cube y2 will be this minus this, which is equal to 0.006. Delta cube y3 will be equal to this minus this, 0.006. Delta 4yi will be delta 4y1 will be equal to this minus this. Obviously they are same, so the value will be 0. Delta 4y2 will be this minus this. The value will be 0. So one more subtraction which we can perform is delta 5. Delta 5yi. So delta 5y1 will be equal to 0. Okay. So this is how we constructed the forward difference table for the above question so that we can solve this. हमसे पूछा क्या गया है? हमसे पूछा गया है to find the order of the interpolating polynomial. अगर हम इस हिसाब से देखें तो हम कहाँ तक हमने इसका subtraction ख़त्म किया, क्योंकि इसके बाद there is no provision of subtraction. ठीक है? So we have to stop over here. So we can say कि order of this polynomial is 5, right? Generally. ठीक? But no. हमेशा आप सब याद रखेंगे whenever, ठीक है, किसी भी ऑर्डर में अगर हर एक वैल्यू कांस्टेंट वैल्यू आ जाए हर एक डिफरेंसेस के रिलेटेड, ठीक है. जैसे फॉर एग्जांपल यहाँ पे डेल्टा क्यूब वाई आई में वी गॉट द कांस्टेंट डिफरेंसेस लाइक 0.006, 0.006, 0.006, राइट. हमें आगे बढ़ने की ज़रूरत ही नहीं थी. वी मस्ट हैव स्टॉप्ड ओवर देयर एंड वी कैन से द ऑर्डर फॉर दिस पर्टिकुलर पॉलिनोमियल is 3. The reason is after that whenever you perform the subtraction you get the value equal to 0 and 0 means nothing, राइट. सो जहाँ पे भी आपको कांस्टेंट, अगर आप ऐसा होता कि ये कांस्टेंट वैल्यूज़ नहीं होते, यहाँ पे 6 होता, 7 होता, 8 होता, फिर हमें कुछ सब्ट्रैक्शन मिलते 1 या 1 2 मिलता या लास्ट जो भी वैल्यू मिलता, कांस्टेंट कहीं पे भी नहीं आता, तब जाके हम कहते कि इस क्वेश्चन का जो है पॉलिनोमियल ऑर्डर जो है वो 5 है. बट इन दिस पर्टिकुलर क्वेश्चन वी गेट द कांस्टेंट वैल्यू under third order forward differences. So the order for this particular question is 3. So let me write it over here. By inspecting the tables we find that third order differences are constant, right? And the higher order differences are 0. So from these facts we conclude that the required order of interpolating polynomial is 3. Okay. So this was one of the questions. Let us see one more question, how we can solve. You can have another type of questions as well. It's not necessary, but majoritarily the questions would be of this type. Okay. So if you will get a question like this, construct the forward difference table and find delta 4 f of 1 if f of 1 is equal to 1, f of 2 is equal to 3, f of 3 is equal to 8, f of 4 is equal to 15, and f of 5 is equal to 25. Okay. So how can we solve this question? Fine. Solution. The first thing is, in this question what we have to find is, we have to find the fourth order polynomial of this particular function when our function will have the value of x is equal to 1. Okay. So firstly, again we have to construct the forward difference table. So xi yi, हमेशा याद रखना ये जो f1 है 2 है, this is f when x is equal to 2. So that means 1 2 3 4 5, x values have 1 2 3 4 and 5. So when x is equal to 1, y is equal to 1. This is 3, this is 8, this is 15, and this is 25. Now construct the table. First order, 3 minus 2, 1 is 2, so 2. 8 minus 3 is 5. 15 minus 8 is 7, and 25 minus 15 is 10. Easy. Second order, because we can further make differences. That is the reason why we go for second order. 5 minus 2 is 3. 7 minus 5 is 2. 10 minus 7 is 3. Further we can make differences. Cube. So this is 2 minus, this is minus 1. 3 minus 2 is 1. And delta 4 yi will be 1 minus minus 1. That will be 2. Okay. Okay, this is the table which we constructed. Now what we have to do is, हमें क्या find out करना है? मुझे find out करना है fourth order में f1 का क्या value है. f1 means the value at x. ठीक है ना. First x का value जब 1 होगा उस time पे delta 4 का क्या value है? The value is 2. So we can write, therefore the value of delta 4 f of 1 is equal to 2. Done. So you can have a similar type of questions where you have to see either the polynomials, or you will get the questions like this. Thank you so much. Have a nice day.